speaking of polynomials, let's talk about some of the things you should know for polynomials. Yeah, polynomials are pretty common for algebra, and usually you see this either it's given in the problem somehow, or you have to like write an equation based on the problem or a system of equations that includes polynomials. So anything, and yeah, so the first thing that I think you should know about polynomials is the binomial theorem. I think anyone that's taken statistics definitely knows this, or some like pre-calculus course. So binomial theorem is basically a way to expand a polynomial, and it's basically it's used to expand anything in the form a plus b to the n. So the basic definition of this, I'll write out first, then I explain, is n choose 0 times a to the n plus n choose 1 times a to the n minus 1 times b, etc. So, and this goes all the way to n choose n times b to the n. As you can see, the powers of a keep going down, and then powers of b keep going up. So that's basically how the binomial theorem goes, and it's useful for expansion. Believe it or not, there's actually more uses. This is like more common than you think, like having to expand this. So I think it's just good to know. And oh yeah, if you don't know what choose is, this is the notation I use for choose, and what this is basically equal to is n factorial. So if you're doing a choose, if you're doing x choose y, for example, that is just x factorial divided by y factorial times x minus y factorial. That's the definition of it. It's, yeah, that's how you define it. And if you know that, then you can be able to use the binomial theorem. Another important thing is Vietas. So that's just a way to find the sum and product of roots. I'm sure you all know of Vietas for like second degree polynomials, but for an nth degree polynomial, so nth degree polynomial, it will just be simply how to find the sum of roots. It's just negative the second coefficient, so I'll denote that as a sub n minus 1 divided by the first coefficient, so that's just a sub n, the coefficient of the highest power in the thing, and then that's just sum of roots. And then for product of roots, it's negative 1 to the n times the constant term divided by the coefficient of the largest power. So that's product of roots. I think this is important because it allows you to find relationships in the roots, and then you can use this to figure out the actual roots of the equation, the roots being the solutions of the polynomial. Yeah, the first and these two are very useful. And after you find these roots, you can further manipulate. You can plug them in. You can substitute. You can and do other things with them. So I think it's important to know how to do that. And then finally, with polynomials, the most important thing by far is knowing how to factor. So I'm sure everyone has done 2 by 2 factoring. Sorry, second degree polynomial factoring, and that the answer is always in the form a minus x minus a times x minus b, and then maybe multiplied by some constant like j or something, right? Or like n. And that's if you can factor something out of the equation beforehand. And what this does is it gives you the roots. If you plug in, so if this equation equals 0, you can just find x values of x. So for values of x equals a and x equals b, then the equation is satisfied. So that's how you find the roots when you factor. And that's for 2 dimension. And then if you want to rewrite this as like the expanded polynomial, you just use FOIL, first outside inside last, to expand it. That's pretty basic. And then if you plug in 1 for x, then you get the sum of the coefficients of the equation, which is pretty useful. And then for a basic polynomial, it's good to write it in the form f of x equals a or n times x minus a times x minus b times x minus c, etc. Because in the factored form, it's much easier to work with, and sometimes when you after you factor, you will be able to cancel out some kind of term from within the factored form, because it's like separated into because you're multiplying it, because after you factor, all the terms are multiplied, so it's easier to cancel something out. Whereas when you're adding, it's not very possible, right? Unless you factor out a constant or something. Know how to do this factoring and things like that with complex numbers, because sometimes you won't be able to factor with whole numbers. And if you use for second degree polynomials, you can use the negative b plus or minus square root of b squared plus minus 4ac over 2a to get you the roots. And sometimes this is a complex root, so it's you write in the same format. It's just a complex number.